In this video, I tried to use a screenshot to show you how to solve the Go programming model. So first, this is the initial setting in the Excel solver for the case STS and the company. So now that you can see, you have different constraints. So here we have our results constraints. So here is the demand constraints, and we also have a goal related constraints. So now you're ready to actually solve your Go programming model. So for first see the we first see the weighted Go programming method. So here you can see this is the initial setting for the weighted Go programming problem. So we need actually first to set up the goals, the weights. So here in this setting, now you can see we have the weights defined here. I take it for granted. I just put the all1 as weights for each goal. You actually can try different kind of weights and see how the solution will be changed. So then here, this cell is the objective function. Basically is a sigma k wk times dk plus. So this is the objective for weighted Go programming. So in this picture, you can see how will you actually solve this problem. It's pretty straightforward. So you put here your objective as the cell, this cell. We define a weighted objective for your problem. All the others are same. So you have the theorem variables, you have initial constraints. Now you can actually click solve. So this picture shows you the weighted Go programming solutions. Now you can see you have a final solution for your deviation variables. You have the minimized value for D plus in this column. And now we can see the investment costs. Actually, you reach the goal by minimize the D plus value. So here, you can see here. And for average travel time is also satisfied. And for another goal, so we actually did not reach the goal. But this is one solution you can offer. So here this is a objective function value for 4 different derivation variables. Now let's see how to solve a ranked Go programming model. Here, this picture shows the solver setting. So I just show the R1 problem. So here in this page, this is the R1 problem. We set the investment cost as the objective. So now you can see we have an objective cell or the objective function for R1 problem is here. Basically, this cell C16. All the decision variables and the constraints are same as the initial Go programming model we presented in the lecture. So now you can click solve to solve the R1 problem. So first, this is a solution for our R1 problem. We can highlight the solutions for first for the deviation variables. So you remember the objective is to minimize. So this is the objective. So minimize the D1 plus. After we solve this problem, we get the optimal solution for investment cost for D1 plus. In other words, we got D1 plus optimal solution equals to 0. So we can actually put this value here. So it's called the best value for D plus for the R1 problem. Now you can say for other objectives or the goals, not necessary, we satisfy all the goals. So we just move on from the R1 problem to R2 problem now. We have tried to solve the R1 problem. So in this picture, I show you the R2 problem setting. If you still remember, so our objective is to minimize the second goals over as achievement deviation variable dr plus d2 plus, which is shown here. So monthly costs. So this is the objective function now. And we also recorded the best value for D1 plus star as a 0. So we just record this value here. And next we need to add an extra constant for your R2 problem. Now you can see I actually add the constant here. So if we try to interpret this constant, this actually is add a D1 plus equals to 0. So that's what we add the extra constant. Then we're done. You can solve this problem, R2 problem, by click solve. This is the solution from the R2 problem. So we can make notes here. This is R2 problem solution. So if we expand this picture, now you can see the first, so the best value here remains. So it's D1 plus optimal solution from R1 remains. And here, this is a D2 plus optimal solution from R2. So if you want to continue with this method, then you can continue to solve a R3 problem by minimize D3 plus and add a constant D2 plus equals to 15. And R4 problem, you try to minimize D4 plus and add D3 equals to the D3 plus star. If you really try, you will see this is actually the final solution you will get from this case. So we do not actually continue with the process. You give it a try. If you compare the weighted Go programming solution and the ranked Go programming solution, you may say, okay, you get the same result, but still there's a coincidence. There's no standard rule. They should be same. So they often different. So you decide which method to use in different situations. But think about you should be cautious to use a weighted sum method, weighted Go programming method. So that's it for this video. Thank you.